Now, we take up one PERT problem. So one illustration I've taken here based on PERT. Here we are given activities 1 to 2, 1 to 3, 1 to 4, and 2 to 5, 3 to 5, 4 to 6, 5 to 6, and three different times are given here. Times. So see the difference. Earlier we had given only one time. Okay. Here three different times are given. Estimated durations, optimistic, most likely, and pessimistic. uh, he is asking, draw the project network, find the expected duration and variance of each activity, what is the expected project's length, calculate the variance and standard deviation of project length, what is the probability that the project will be completed. Why we are using probability? These are estimated times, isn't it? Not definite times. At least 4 weeks earlier than expected, no more than 4 weeks later than expected. Some Z values are given. You will be given the Z values. Normal distribution values are given here. If the project is 19 weeks due in 19 weeks, what is the probability of meeting the due date? So 0.5 is this much p-value, 0.67, the different normal distribution values are given here. So now, first we should draw the network diagram. So then you find out the T values, TL values, same procedure I am using. First up, before that, what you have to do, you have to calculate estimated time, single estimated time for these three. Okay. So now I've taken activities on this, optimistic times TO, and TM most likely, pessimistic is TP. Here the formula for calculation of single period time, TE is equal to T naught plus 4TM plus TP by whole divided by 6. This will give you single period time, single times. So that is T naught is, we have 1 plus 4 of TM plus 7 whole divided by 6. Like that, for every activity you have to calculate the TE values. You will get these values. Just you substitute the values, respective values, you will get this. Then variance also we are calculating. Variance formula is TP minus T naught by 6 whole divided by 6 whole to the power 2. That is square, whole square. TP minus T naught by 6 whole square. So that will give you the variance of the project. So once you complete this table, then we have to draw the network diagram. So first you draw the network diagram. So 1 to 2, this is simple because you are given the directly activities are given. So this is easy now. Earlier in the CPM, we were given some predecessor activities like that. Here simply the activities are given 1 to 2. So 1, 2, 3, like this you can draw 1 to 4, 2 to 5, 3 to 5, 4 to 6, 5 to 6, like this you can give. Then just you represent the single time periods. 2, this is 4. So third activity is 3, fourth activity is 1, fifth activity is 6, and sixth activity is 5, seventh activity is 7. Okay, so like that you can give the values. So now use the forward pass method. Instead of writing like this, directly also you can do, first you keep T is equal to 0, so 0 plus 2 is 2 here. So then go to TE3. TE3 is 0 plus 3 is 3. So TE4, sorry, T4, this TE3 is 0 plus 4 is 4. TE4, that is 0 plus 3 is 3. T5, maximum of these two you have to check. This TE3 value and TE2 values you should take. So maximum is 10. So then T6, so maximum of these two, T is 5 as well as TE4 you have to check. Whichever is maximum, that is you have taken, that can be taken 17. So now backward pass method, backward 17, TE must be equals to TL now. So 17 is equal to 17. Then you go to 5. So that is T17, TL17 minus 7, this is 10. Then go to 4. T6, TL6 minus 5, that will give you this value. Okay. This is 5. Okay. Then this is TL6 is equal to 17, that is TL5 is TL6 minus 7, that is 10. TL4, that is equal to TL6 minus of 17. So this is actually 17, 17 minus 5, okay, 13, okay, that is 12, 12, and TL3, TL3 is nothing but TL5 minus 6, that is 4, TL2, TL5 minus 1, that is equal to 10 minus 1 is equal to 9. So like this you can take the values, TL value to TL1 is equal to 0. So you take like this, you will get the values 17 minus 4. Okay. So now what he is asking here, observe the critical path. What is the critical path here? Just we go to the previous slide. What is the critical path where TE and TL values are same? That is a critical path. This is one. Another one is next. You can go to this 3, then this, then this one. That is 1, 4, 1, 2, 3, 3 to 5, 5 to 6 is a critical path. So 1, 2, 3, 3 to 5, 5 to 6 is a critical path. So now you have to find out what is the duration of the variance. Length of the project is nothing but duration. Means the sum of the variances of the critical activities. What are the critical activities? 1 to 2 is 1, then 1 to 3 is 1, 3 to 5 is another one, 5 to 6 is another one. Their variances you take up. Some of those variances will give you the project's length, or directly 17 days from the network diagram also you can write. Variance of the project is nothing but sum of the variances of the critical activities. Critical activities 1 to 3 is 1, 3 to 5 is another one, 5 to 6, and respective variances. Variance is nothing but from here you have to take 3 to 5. So this one 1 to 3, 1 to 3 is 1, then 3 to 5, 3 to 5 is 4, then 5 to 6, like this you have to take 5 to 6. Okay. Sorry, variance of the projects. That is 9. 1 plus 4 plus 4 is 9. Variance of the project's length. So duration from the network diagram you can give. Variance of the project's length you can calculate like this. And standard deviation means the square root of this. The variance will give you the standard deviation. Now due date we are calculating. Z is equal to due date minus expected date of completion divided by variance, square root of variance. That is TS is equal to 13. Just to substitute the TS 13 here. Due minus TE, that is 13 minus 17. TS is 13. Okay. 13 minus 17 whole divided by 3, that is equal to minus 1.33. Okay. Next, therefore, P TS is less than or equal to 13, that is equal to P of Z value is less than or equal to 1.33. So this lies between, so this is less than or equal to, no? Less than means what you have to do, 0.5 minus this value you should take, that will you get 0.18%. Another one, TS is equal to 21. Okay, TS is equal to 21. That means TS is 21 minus 17 whole divided by 3. That is 1.33. It is also less than 1. So 1.33 positive side. This was negative side actually. This is on the left hand side. So 0.5 minus this portion you have to deduct. That is why we did like this. Here positive side this one. This plus this you have to do. So that is 0.5 plus 0.4082. This is normal distribution mean. This is negative sign. This is positive side. This is on the positive side, this value. So we should add till here is 0.5, from here is this much. So total is 90.82%. So when the due date is 19 weeks, so Z is equal to 19 minus 17 divided by 3, that is 0.67. So the probability of meeting the due date is this, probability of Z is less than or equal to 0.67, that is equal to positive value 0.5 plus this table value is 0.2482 from the table. We are given a table values. So that from that we can find out this table value, and this value we got from the table. So that is 74.86. So the probability of not meeting the due date is 1 minus, you have to do this one, not meeting. Okay, no? So that is 25.14.